Hi, welcome to my YouTube channel Tech Talk Forum. Today we will discuss what is Bigquery. Bigquery is a Google Cloud fully managed petabyte scale and cost effective analytics data warehouse that lets you run analytics over vast amounts of data in near real time. And it is a warehouse, data warehouse. BigQuery is a data warehouse where you can store a huge amount of data in petabytes, and maybe over that, and that you can categorize in different way, and you can access it, store it, and you can access it for your analytic purpose. Okay. The BigQuery is a service provided by Google Cloud Platform. There are many services in the Google Cloud Platform. One is compute, identity, security, networking, big data, storage, database, and these are the categories. Out of that, big data is the one category in which BigQuery is a one service of Google Cloud Platform, right? Okay. Now, what is the difference between data lake and data warehouse? Data lake is a storage repository designed to capture and store a large amount of all types of raw data. The data can be structured, semi-structured, and unstructured. Okay, data lake having the data which is either structured or semi-structured or unstructured. It is a repository of data. While is a centralized repository and information system used to develop insights and information decision with the business intelligence. Data warehouse store organized data from multiple sources. Okay, data warehouse store organized data, while data lake stores unstructured, semi-structured, and structured data. That means it is a collection of data in various format. It may be the social data from the social media. It may be the data from the text. It may be the JSON data. It may be the data from the database, etc. But data warehouse in an organized way. It is when it is converted and organized this data, then we call it the data warehouse. Okay. Next, the question is why BigQuery is very fast to access. Petabyte size of data is stored in the BigQuery tables. There is three things which is very important. First is the partition table. Let's see what is the partition table. What partition table is divided into segments called partitions that make it easier to manage and query your data. In partition table, data is stored in physical blocks, each of which holds one partition of data. Right? It stores data in physical block, different physical blocks. That means one partition is stored in one uh, physical block of the one physical block of the hard disk. Okay, if a query is if a query is uses a qualifying filter on the value of partition column, the BigQuery can scan the partition that match the filter and skip the remaining partitions. Okay, advantage that suppose there is data for 10 years or 10 years data is there, and you want to fetch data for a particular date. In that case, if you partition the table on the basis of date, then the all data belonging to that date will be stored in one physical block. And when you query, in that case, search will directly go to the that physical block where that data of that particular date is stored, and it fetches it very fast in that way. Otherwise, what happens in RDBMS or DBMS system, it scans the data, entire table of gigabyte or terabyte of data to find out the particular date. And here it will not scan the entire data, but it will only directly hit to the particular date or particular partition, physical block of the partition. That is the one way it is very fast. Second is the keyword is the clustered table. That means clustered tables in BigQuery are tables that have a user-defined column sort order using clustered columns. Clustered tables can improve query performance and reduce query cost. Okay. In BigQuery, a clustered column is a user-defined table property that sorts storage blocks based on values of clustered columns. So actually, the cluster means it is a kind of sorting. It is a sorting within the partition. When you do the partition as well as you do the clustering, then if partition does the partition of the table, and cluster do the sorting of the data within the partition if partition is done. So cluster means basically a sorting. Then another important keyword and important thing in BigQuery, why BigQuery fetches the data so fast, is the sharding. Sharding makes horizontal scaling possible by partitioning the database into smaller, more manageable parts. Then deploys the deploying the parts across the cluster of machine. That will be more clear in the figure in the coming screen. Okay, data queries are routed to the corresponding server automatically, usually with rules embedded in application logic and or a query router. Now, in the next screen, the same thing, partition, clustering, and sharding is explained in a graphical way. First, see this. First, see this screen. If you see this screen carefully, then you can watch that in the left side there are data which is stored in haphazardly. Suppose in the stored haphazardly in the in the table. But when you do the partitioning by date, then all data having this particular date will be stored in one physical block, and another data with different date, all the data having the date 4th August will be stored in different block. Likewise, 5th and 6th data of 5th or 6th August. This way, this is called partitioning. Okay, that is data of different date is stored in different block. Okay, now this you can see in it is more clear. Here you can see there is partition 1 is stored in the block physical block 1. Partition 2 is stored in physical block 2. Partition 3 is stored in physical block 3. And partition 4 is stored in physical block 4. Okay, now this is the partition. This is partition by date. So date is stored here, and it is clustered by the country. That means sorting is done on the uh, column country. So you can see here it is the sorted. Likewise, this is called clustering. It is sorting. Here also it is sorting. Here also it is sorting, sorting. And this is the partition. This is the one partition. This is one partition. This is one partition, and this is one partition. Here the data is haphazardly. So after doing partitioning and clustering, data will be like this. So if you have a data of 10 years, 10 years, 20 years, in that case, you can store the data either if you store the data on the date wise partition, then it will store like this. Okay. Now another important thing comes is the sharding. Sharding, as I told in the previous screen, the sharding means it is the division. You can see sharding means it is a horizontal scaling possible by partitioning. It divides the query. Suppose you fire a query, uh, fire a query having a large data, and it is table is partitioned and also table is clustered. That means sorted. So if you fire a large query which has to return a huge amount of data, then there will be one root server. This is happening in BigQuery automatically. Will be the root server. This root server will be uh, will manage the entire thing overall, but it will first divide into these three different virtual machines, which will be created by the BigQuery in the backend. It will and divide into the or assign the job or assign the task of dividing the query by different virtual machine. Now this virtual machine will break up the large query into multiple parts. Okay, so that it can fetch quickly, and also it will record which query is stored where, which query part of the query is stored where, and it is passing to which leaf nodes. It is called leaf nodes, where this query will be individually processed. That means, for example, if you fire the particular date, 1st January, uh, you fire the query for the first journey or particular year. So then it will and there is suppose 100 GB of data to be fetched. Then data will be this query will be divided by this mixture servers called, we can call it a mixture server. It will be divided here, and it will be sent to the leaf nodes. Then these leaf nodes, suppose there are 10 leaf nodes, then all of these leaf nodes will handle 10 GB of data separately, and this will access the database in separately. Okay, it will handle separate set of data. It will handle separate set of data. It will handle separate set of data, like all the leaf nodes, or which is also the virtual machines. It will access the data, and it will return the individual queries to this mixer servers. Then this mixer servers will return back to the root server, and finally you will get the answer to the query. So that process is called sharding. Whether it is a dividing your large task into the small task, so that query can become very fast. So why BigQuery is very fast? Fetching data from the using BigQuery is very fast because first is partitioning. So you can divide the data into different physical blocks, date wise, or there are other ways of partitioning, or you can or and you can sort it also. That is called clustering. and this sharding is done automatically by the BigQuery. And these three action, partitioning, clustering, and sharding, makes the BigQuery data fetching very quickly. Okay. Another thing which is important is that partition can be done either on the date wise or data timestamp wise, or it can be on some numeric field. Okay, these three way partition can be done. So that is overall things. I hope you understood this. So thank you very much. If you like this video, please like, share, and subscribe to the channel. So more technical things will be uploaded in the near future. Thank you. Thank you very much.